Alright, let's go. Number 12. The split brain experiments. The surgery that proved a single human skull can contain two separate minds, and they do not always agree. In the 1960s, a neurosurgeon named Joseph Bogan and a neuroscientist named Roger Sperry began operating on patients with severe, uncontrollable epilepsy. The procedure was radical. They severed the corpus callosum, the thick bundle of roughly 200 million nerve fibers that connects the left and right hemispheres of the brain. The seizures stopped. The patients, as far as anyone could initially tell, seemed normal. Then Sperry began testing them, and what he found changed the philosophy of mind permanently. When an image was flashed only to the left visual field, which is processed by the right hemisphere, the patient could not verbally identify the object, because speech is controlled by the left hemisphere. But the patient's left hand, controlled by the right hemisphere, could reach out and pick up the correct object from a hidden tray. One half of the brain knew, the other half did not, and both halves belonged, apparently, to the same person. The experiments escalated. In one famous case, a patient's left hand began buttoning a shirt, while the right hand, moments later, unbuttoned it. Another patient's left hand tried to strike his wife, while his right hand moved to restrain it. The two hemispheres, disconnected, had different preferences, different reactions, and, most disturbingly, different personalities. Some tests suggested one hemisphere was religious and the other atheist. One wanted to be an architect, the other wanted to be a race car driver. The implication, which the scientific community has never fully digested, is that consciousness may not be one thing. It may be two things: sharing a skull, ordinarily networked so tightly that they appear to be a single self. Cut the network, and the illusion falls apart. The unsettling question is what the two selves are doing in your head right now when the connection is intact, and whether the you reading this sentence is the whole system, or only the half that gets to speak. Number 11. Blindsight. The condition where a person is completely blind and can still catch a ball thrown at their face. In 1974, a psychologist named Lawrence Weisskranz was studying a patient known in the literature as DB. DB had suffered damage to his primary visual cortex, the part of the brain that produces conscious visual experience. He was, by every clinical measure, blind in one half of his visual field. He reported seeing nothing. Ask him what was in front of him, and he said darkness. Then Weisskranz asked him to guess. DB was shown lights, shapes, and moving objects in his blind field and asked to point at them, even though he insisted he could not see them. He pointed accurately. He tracked movement. He identified whether a line was horizontal or vertical. His accuracy was far above chance, sometimes above 95%, for stimuli he swore he had no awareness of. When shown emotional facial expressions in his blind field, his own emotional state shifted to match, even though he had no idea what he had been shown. The condition is called blindsight, and it has since been documented in dozens of patients. Their brains are seeing. They are just not experiencing what they see. The terrifying implication is what this reveals about consciousness itself. Vision, it turns out, is not a single process. It is a stack of processes, and only the top layer produces the experience of seeing. Beneath it, other pathways are quietly extracting information, guiding movements, triggering emotions, all without any awareness. And if vision works this way, so may everything else. Language, memory, decision-making, every function you feel you are consciously performing may be shadowed by a second, silent version of itself, doing the same work in the dark. You may already be blindsided to most of what your own brain does. Number 10. The Halle neuron. The discovery that individual cells in your brain may fire only for a single person, a single concept, a single face, as if consciousness is built one flashcard at a time. In 2005, a neuroscientist named Rodrigo Quiroga was studying patients who had electrodes implanted in their brains as part of epilepsy treatment. He was recording the activity of individual neurons in the medial temporal lobe, the area involved in memory. He showed the patients photographs, drawings, and written names of celebrities, landmarks, and objects. And he found something no one had expected. In one patient, a single neuron fired every time an image of Halle appeared, whether it was a photograph, a drawing, or her name written in text. It did not fire for anyone else. It fired for Halle Berry, in every form, and only for Halle Berry. In another patient, a neuron fired specifically for Jennifer Aniston. In another, a specific cell responded to images of the Sydney Opera House. The neurons were highly selective, highly abstract, and consistent across time. The finding suggests something disturbing about how memory and identity may be stored in the brain. Concepts, people, places, the building blocks of your world may be encoded, at least in part, in individual cells, which means those cells can die. Every stroke, every concussion, every night of insufficient sleep destroys neurons. Some of them are, presumably, the ones holding faces you love, memories you cherish, moments you assume are permanent. And the arithmetic is worse. The brain has roughly 86 billion neurons. You have known perhaps a few thousand people, seen perhaps a few million images, experienced perhaps 100 million moments. If any significant fraction of these are stored in dedicated cells, then large portions of your identity are held in structures smaller than a grain of sand, with no backup and with a slow, silent death rate that begins the day you are born. Number 9. Change blindness. The phenomenon that proves you are not seeing what you think you are seeing and never have been. In the 1990s, psychologists Ronald Rensink and Daniel Simons began running an experiment that quietly upended the field of perception. They showed subjects a photograph, briefly blanked the screen, and then showed the same photograph again, except a large obvious element had changed. A building had shifted, a person's clothing had changed color, an engine had been added to an airplane. The subjects usually did not notice, even when told a change was coming, even when they stared directly at it. The experiment was refined into terrifying territory. In one version, an experimenter stopped a stranger on the street to ask for directions. During the conversation, two workers carrying a large door walked between them, and while the door blocked the stranger's view, the original experimenter was replaced by a completely different person. Different height, different clothing, different voice. Roughly half of the strangers continued the conversation without noticing that the person they were talking to had been swapped mid-sentence. The disturbing conclusion is that visual experience is not what it feels like. It feels rich, continuous, and detailed. It is actually a thin, patched-together construction, updated only where your attention is currently pointed. The rest is filled in by memory, expectation, and guesswork, which means the world you see is not the world. It is a story your brain is telling you, updated slowly, corrected reluctantly, and every moment you assume you are looking at reality, you are actually looking at a summary, one so incomplete that entire human beings can be swapped in front of you without triggering an alarm. Number 8. False memories implanted on command. The discovery that a psychologist can plant a memory of an event that never happened, and you will defend it as the truth. In 1995, cognitive psychologist Elizabeth Loftus published a study that became known as Lost in the Mall. She and her team recruited adult subjects and asked them to recall 4 childhood events described by a family member. 3 of the events were real. The 4th, being lost in a shopping mall at around age 5, becoming terrified, and being rescued by an elderly stranger, was fabricated. About 25% of the subjects remembered the fake event. They provided details. They described the store. They named the emotions. Some of them added elements the researchers had never mentioned. When told the memory was false, several refused to believe it, insisting they remembered the incident clearly. Later experiments went further. Researchers successfully implanted false memories of being attacked by an animal, of being hospitalized as a child, of committing a crime that had never occurred. In one 2015 study, 70% of participants were led to remember a crime they had committed as a teenager, a theft, an assault, complete with sensory detail. The memories were manufactured in fewer than 3 interview sessions. The terrifying implication is that memory is not a recording. It is a reconstruction, performed fresh every time you remember something, and vulnerable to editing by suggestion, emotion, social pressure, and time. Every memory you have of your own life may contain fabricated elements. Some of your most cherished memories may be entirely false, and there is no internal alarm that fires when a memory is fake. Invented events feel exactly as real as genuine ones. Your autobiography, in the strictest sense, is not entirely non-fiction, and you have no way of knowing which pages are the invented ones. Number 7. The delayed consciousness of free will. The experiments that suggest your brain decides what you will do before you know you have decided. In the early 1980s, a neuroscientist named Benjamin Libet ran an experiment that has haunted the field of consciousness ever since. He asked subjects to flex their wrist at a moment of their own choosing, and to note precisely when they made the conscious decision to move. Meanwhile, electrodes measured brain activity. The result was devastating. The brain's motor preparation activity, the readiness potential, began roughly 350 milliseconds before the subjects reported deciding to move. The brain had already begun preparing the action before the person was consciously aware of choosing to do it. Later experiments, using functional MRI, pushed the delay much further. In a 2008 study by John Dylan Haynes and colleagues, brain activity in specific regions predicted a subject's decision, left button or right button, up to 10 full seconds before the subject reported making the choice. 10 seconds. The brain apparently had already decided. The conscious feeling of choosing was a report of a decision that had already happened, dressed up as an act of will. The unsettling interpretation is that free will, as we experience it, may be a story the brain tells itself after the fact, a narrator explaining actions that were already underway. You feel like you are choosing. The neurons feel like they are firing. And when the two are timed against each other, the neurons win, every time. Not every neuroscientist accepts this reading. The debate is fierce and unresolved, but the raw data has never been overturned. Every replication of Libet's paradigm, in every generation of technology, has confirmed the delay. Your decisions may not be yours in the way you assume. They may just be yours to narrate, after the brain has already made them. Number 6. The terror management discovery. The finding that almost every belief you hold may be a defense against a single fact you cannot admit knowing. In the mid-1980s, 3 social psychologists, Jeff Greenberg, Sheldon Solomon, and Tom Pyszczynski, proposed a theory so uncomfortable that it took the field years to take it seriously. They called it terror management theory. The claim was simple. The human brain, uniquely among animals, is intelligent enough to fully understand that it will die, and that awareness is so unbearable that the brain has evolved elaborate systems to suppress and manage it. Systems that quietly govern much of human behavior. Over the following 4 decades, the theory was tested in hundreds of experiments, and the results were disturbingly consistent. When subjects were reminded of their mortality, even subtly, even briefly, even without their awareness, their behavior changed. They became more attached to their cultural worldview, they judged rule breakers more harshly, they favored their own group more strongly. They gave larger amounts of money to people who shared their beliefs, and smaller amounts to those who did not. They became more religious, more nationalistic, more materialistic. Reminders of death shifted political preferences, made people more punitive, made them more likely to endorse violence against outsiders. The theory suggests that many of the beliefs you hold most passionately, your values, your identity, your loyalties, may not be reasoned conclusions. They may be defenses, cultural scaffolding your brain uses to hide from a fact it cannot process, that you personally will one day cease to exist. If terror management is correct, then your worldview is not a map of reality, it is a wall. And on the other side of that wall is the one thing your brain has spent your entire life pretending not to know. Number 5. The dead salmon experiment. The neuroscience study that scanned a dead fish, found brain activity, and revealed a decade of published research had been quietly wrong. In 2009, a neuroscientist named Craig Bennett placed a dead Atlantic salmon inside a functional MRI scanner. The fish had been purchased at a market. It was, in every sense, extremely dead. Bennett showed it a series of photographs of humans in social situations and asked it to determine what emotion the humans were feeling. The scanner detected significant brain activity in the salmon. The point of the experiment was not that the fish was thinking. The point was that functional MRI, the primary tool used to map brain activity in modern neuroscience, produces false positives. Every fMRI scan analyzes thousands of tiny brain regions, and by pure statistical chance, some of them will appear active when nothing is happening. Bennett's fish was a demonstration that if researchers did not carefully correct for these false positives, they would find significant brain activity in a corpse. The follow-up analysis was worse. Bennett estimated that up to 40% of published fMRI studies at the time had failed to apply the necessary statistical corrections, which meant a substantial fraction of the modern brain imaging literature. Thousands of papers claiming to identify the neural basis of love, morality, decision-making, memory, was reporting results potentially indistinguishable from a dead fish's brain. The field has since tightened its standards, but most of those older studies have never been retracted. They are still cited. Their findings still appear in textbooks, in popular science books, in news articles about the brain region for this and that. Somewhere in the accumulated public knowledge about how your mind works, there are conclusions built on data no more meaningful than the neural life of a market-bought salmon, and no one has ever gone back to sort out which conclusions those were. Number 4. Cotard's syndrome. The rare condition where a living person becomes absolutely convinced that they are dead, and no amount of evidence will change their mind. In 1880, a French neurologist named Jules Cotard described a patient he called Mademoiselle X. She insisted that she had no brain, no nerves, no chest, no stomach, and no intestines. She said she was made only of skin and bone, that she was already dead, and that God and the devil did not exist. She refused to eat, believing that a dead body did not need food, and she eventually died of starvation. The condition, now called Cotard's syndrome or walking corpse syndrome, has since been documented in medical literature dozens of times. The symptoms cluster around a specific delusion. The patient believes they are dead, or do not exist, or are missing internal organs. Some believe they are immortal because a dead body cannot die again. Some believe they are decomposing. Some can smell their own rotting flesh, though their body is medically healthy. The neurological cause appears to involve a disconnection between the brain's face recognition system and the emotional processing system. When the patient looks in the mirror, they see their face, but the emotional signal that normally accompanies self-recognition is missing. The brain, presented with a face it should feel connected to but does not, arrives at the most parsimonious explanation available. The face belongs to someone who is dead. The disturbing implication is what this reveals about the ordinary sensation of being alive. Feeling alive, it turns out, is not automatic. It is a signal, a subtle, constant hum of self-recognition generated by a specific brain circuit. When that circuit fails, aliveness itself vanishes as a felt experience, even though the body continues to walk, breathe, and speak, which means that the ordinary certainty you have, that you are alive, that you exist, that you are here, is not a fact about reality. It is a feeling, and the feeling can be turned off. Number 3. The bicameral mind theory. The proposal that ancient humans did not have consciousness, they had voices in their heads and mistook them for gods. In 1976, a Princeton psychologist named Julian Jaynes published a book called The Origin of Consciousness in the Breakdown of the Bicameral Mind. It made a claim so bizarre that most academics dismissed it on sight. Jaynes argued that consciousness as we know it, the inner narrator, the sense of a self reflecting on its own thoughts, is a recent development in human history, arising only about 3,000 years ago. Before that, Jaynes said, human beings operated with a bicameral mind. The two hemispheres of the brain functioned as separate systems, and the right hemisphere's output was experienced by the left hemisphere as an external voice, a voice that gave commands, offered guidance, and made decisions in moments of crisis. Ancient humans, according to Jaynes, did not think, they heard, and they interpreted the voices as gods, ancestors, or spirits. His evidence was literary and archaeological. In the Iliad, characters do not deliberate. They receive instructions from Athena, from Apollo, from Zeus. The interior monologue that dominates modern literature is essentially absent from the earliest written texts. Somewhere between the composition of the Iliad and the composition of the Odyssey, something changed. Human beings began to describe themselves as thinking rather than hearing. The theory has always been controversial. Most neuroscientists reject its strong form, but elements of it have quietly gained support. Auditory hallucinations remain common. Hearing your name called when no one is there is reported by a substantial fraction of the population. Schizophrenia's characteristic voices may be a modern misfire of exactly the mechanism Jaynes described. Studies of hearing voices experiences across cultures suggest that the phenomenon is more common and more accepted than modern Western science admits. If Jaynes was even partly right, the implication is startling. Consciousness may not be a biological given. It may be a cultural technology, taught and inherited, that overlays a much older cognitive architecture. And the voices that ancient people heard may still be there, in the modern brain, silenced only by a habit of interpretation your culture taught you the moment you learned to speak. Number 2. The global workspace and the simulation of a self. The dominant theory of consciousness among neuroscientists, and the reason many of them quietly suspect there may not be anyone home. In the late 1980s, cognitive scientist Bernard Baars proposed a theory that has since become one of the leading frameworks in consciousness research, the global workspace. The idea is that the brain is a collection of hundreds of specialized modules for vision, language, memory, motor control, planning, each running in parallel, mostly in the dark. Consciousness is what happens when the results of one of these modules are broadcast to all the others, becoming globally available for reasoning, memory, and speech. In this view, consciousness is not a thing. It is a broadcast. There is no central observer, no inner homunculus watching the show. There is only a network of processors, and at any given moment, one signal is on the loudspeaker. The disturbing extension of the theory, developed by researchers including Michael Graziano, is that the feeling of being a self, the sensation that someone is having your experiences, may be a model the brain constructs, in the same way it constructs models of external objects. The brain builds a representation of the body. It builds a representation of the environment. And it builds a representation of the mind itself, a simplified cartoon version of its own workings, tagged with the label me. That tag is what you feel when you feel like a person. It is a schematic, a user interface the brain uses to keep track of its own processes, and beneath it, there is no additional entity, no ghost in the machine, no observer behind the eyes, just the loudspeaker, and the modules, and a model of a self that the modules generate together. The implication is that you, the specific someone reading this sentence right now, may not exist in the way you feel you do. There is a brain, and there is a process, and there is a self-model, and the self-model insists it is a person. But no one has ever found the person behind the model. Every attempt to locate the observer has come up empty. The head, it seems, may be a room with a very convincing sign on the door, and no one inside. Number 1. The hard problem of consciousness. The single greatest unsolved question about the brain, and the reason some philosophers believe science may never fully explain you. In 1995, an Australian philosopher named David Chalmers gave a talk at a conference in Tucson, Arizona. He proposed a distinction that has organized consciousness research ever since. There are, he said, easy problems and hard problems of consciousness. The easy problems, easy only in comparison, include explaining how the brain processes information, how it distinguishes stimuli, how it integrates memory with perception, how it produces behavior. These are engineering problems, difficult but tractable. The hard problem is different. It is the question of why any of this is accompanied by experience. Why is there something it feels like to see red, to taste chocolate, to be in pain? Nothing in the physical description of the brain requires that these processes feel like anything. In principle, a brain could carry out every one of its functions in total darkness. No inner light, no felt experience, just information moving through matter. But that is not what happens. There is an inner light. There is experience. And no theory in physics, chemistry, biology, or neuroscience explains why. The hard problem has resisted every attack in 3 decades of intense research. Every proposed solution has either failed to solve it or has solved it by redefining it into a form that no longer feels like the original question. Some philosophers now argue that the hard problem may be permanently unanswerable, that our minds, being physical systems, may lack the conceptual tools to understand their own subjective nature, in the same way a calculator cannot understand what it feels like to be a calculator. Others go further. They argue that if experience cannot be derived from physics, then experience may not be reducible to physics at all. Some form of consciousness, some element of feeling, may be a fundamental feature of reality, present in some form at every level, from atoms to galaxies. This is the view called panpsychism, and it is no longer a fringe position. Serious philosophers and physicists now discuss it in mainstream journals. Either possibility is terrifying in its own way. If the hard problem cannot be solved, then the most immediate fact of your existence, that there is something it feels like to be you, is permanently outside the reach of the scientific project that has explained every other feature of the universe. And if consciousness is fundamental, if some flicker of experience exists in every atom, then the world you live in is not a mechanism with a mind added on top. It is a mind, all the way down, and everything you have ever encountered has been, in some sense, awake. The brain is the most complex object in the known universe, and the one thing it cannot do, has never done, and may never be able to do, is explain why it is the thing you are. If you want to see more videos like this, subscribe, like the video, and share with a loyal friend.